Good morning, students. Last two class we started different forms of equation of plane. What are the forms we saw? If normal and distance is given, have to find the equation, and normal perpendicular distance will be given. Next 1.2 vector, 2.1 vector, or 3 points, right? So using those hint, we found out the equation of plane. Parametric form, non-parametric vector form, Cartesian form, like that. Today we are going to see conditions. So only we are going to see 3 conditions today. So what are the 3 conditions? Your first condition is condition for a line to lie in a plane. So we are taking one line, one plane, and we are going to check whether that line lies in a plane. So what will be the condition? This is your first one. And your second one is condition for coplanarity of two planes. What does mean by coplanar? The number of lines lie in the same plane is a coplanar, right? So now we have to check whether the two lines is a coplanar. So what will be the condition we are going to see. And your third one is again equation of your third one will be non-parallel coplanar. So again the two line will be a non-parallel coplanar, and we are going to check. Okay, so these are the 3 headings we are going to see today. So what will be the first one? Condition for a line, that is line lie in a plane is your first condition. Coplanarity of two lines, second condition, and coplanarity non-parallel coplanar condition will be your third one. Is that clear? Okay, so first one, condition for a line to lie in a plane. So here what will be important? Line and plane. So we have to check whether the given line lies on a plane. Okay, so we are taking one line. This is your line, and this is one plane we are taking. Okay, now tell me, what is your x1, y1, z1 points? A, B, C vector, and this is a plane. Okay, so this is a line, this is a plane. Now we have to check whether this line lies in a plane. What is the condition? AA plus BB plus CC equal to 0. That is, you have to take the vector from the first equation and coefficient of xy at the second equation, multiply. If the answer is 0, then you can say that the given line lies in a plane. Is that clear? Next, condition for coplanarity of two lines. Condition for coplanarity of two lines. Okay, so we are taking two lines. Here only we are taking two lines. What are the two lines? R equal to A plus SB vector, R equal to C plus TD vector. So what is your A and C point? B and D vector. Okay, so first always it is a point, second will be a vector, correct? Okay, so we are taking these two lines, and we are going to say these two lines are coplanar when if this C minus A dot B cross D equal to 0. This is your condition. What is the condition? C minus A dot B cross D equal to 0. This is your vector form. And what is your Cartesian form? x2 minus x1, y2 minus y1, z2 minus z1. What is your x1, y1, z1, x2, y2, z2? Points. This is your x2, y2, z2. A is your x1, y1, z1 points. So b1, b2, b3 is your vector of first equation. D1, D2, D3 is your vector of second equation. If all this modulus equal to 0, then you can say that is your Cartesian form. Is that clear? Okay, and your last one, equation of plane containing two non-parallel coplanar. So this will be your non-parallel coplanar. So the vector will not be same. That is the meaning of this non-parallel. Non-parallel means if again two lines we are going to say take, in that two lines that vectors, that is B and D, are non-parallel. Okay, ma? So what is the condition of non-parallel coplanar? So again we are taking two lines. A R equal to A plus SB, R equal to C plus DT are non-parallel coplanar. Non-parallel இது ரெண்டும் ஈக்குவலாக இருக்காது. Okay, now what is your vector equation? This is your vector equation, and here we are not going to check the condition. So for non-parallel coplanar, have to find the vector equation is this one. So what is your equation? R vector equal to A plus TB plus SD, or R vector equal to C plus TB plus SD. Okay, this both equations are one and the same, but here we are taking two lines now. So with the A you can make the first equation, or with C you can make the second equation. Is that clear? Yes. So what is this? Vector equation of a plane containing two non-parallel, right? Two non-parallel coplanar equation. So next, we saw vector equation now. Next we are going to see non-parametric vector equation. So what is your non-parametric vector equation? R minus A dot B cross D equal to 0, or R minus C dot B cross D equal to 0. These are the two lines, okay? R minus A dot B cross D, R minus C dot B cross D equal to 0. And what is it Cartesian form? X minus x1, y minus y1, z minus z1, b1, b2, b3, d1, d2, d3 equal to 0. Okay, so what are the three forms we saw? Condition for a line to lie in a plane, first one. Condition for coplanarity of two lines. Third one, equation of plane containing two non-parallel coplanar lines. Is that clear? Okay, so first again using these three forms we are going to find out the equation of that is, you are going to do your exercise 6.8. So take your exercise 6.8. First question. What is your first question? Show that the two lines are given. Okay. Show that the two lines are coplanar. So we have to show that these two lines are coplanar. Also, we want to find out the vector equation. Is that clear? So two lines is given. We want to find whether these two lines are coplanar. Also we want to find out vector equation. So coplanar, now we have two conditions. One is condition for coplanarity of two lines. Second one, non-parallel coplanar. Correct? Okay. So first here, just see this one. This is your vector. This is point vector. This is point vector. Correct? Okay. Is this two vector are parallel? Parallel means ஒரே மாதிரி இருக்கணும். Is that like that? No. So this is your non-parallel coplanar. Okay, va? Okay. So this is what given. First we have to take it in a form of R equal to A plus SB, R equal to C plus TD. Okay, va? Now what is this one? Point. This vector. This is point. This is vector. So we can take A vector is equal to, this is your point, right? So 5i plus 7j minus 3k vector. This is your A. This is your B. C, D. So B is a vector actually. Correct? So we can take B vector is equal to 4i 4j minus 5k. Next, C vector is equal to 8i 4j 5k. This is your vector. And D vector is equal to 7i plus j plus 3k. So first we have to check whether it is a coplanar. So for finding coplanar, find B cross D first. So what is your B cross D? This and this. That is I j, k. B is 4, 4 minus 5. D is 7, 1, 3. Correct? And if we take determinant of this, you will get I of, again this will go off, you will get, okay, I'll give you the final answer. Okay, so this will be your 17, and if I take minus j, you will get this will go off, so this will be your 47, and plus k, if you take first and third will be go off, and this is your minus 24. So what is your final answer? 17i minus 47j minus 24k vector. What is this one? B cross D vector. Is that clear? So next, C minus A we want to find out. So C minus A means we have to subtract C and A vector. So what answer you will get? 3i minus 3j plus 8k vector. Okay. So what is your coplanar condition? C minus A dot B cross D equal to 0. This is your condition, right? Therefore, C minus A dot B cross D we have to take. So what is your C minus A? 3i minus 3j plus 8k vector. What is your B dot D? 17i minus 47j minus 24k. Correct? So which is equal to, if we multiply 17 into 3 minus 3 into minus 47, my 8 into minus 24. So 17 into 3 is your 51, and this will be your 141, plus into minus is minus 192. Again, if we add, this is 192 minus 192, which is equal to 0. So what we can conclude? Therefore, the given two lines are coplanar. Is that clear? Okay, so we found out coplanar. Next, what we have to find out? Vector equation. So what is your vector equation formula? R vector is equal to A vector plus S B vector plus T D vector. Is that because it is a non-parallel, right? So non-parallel, now you have to use this condition only. Is that okay? So just substitute your A, B, D. That's all. So R vector is equal to 5i 7j minus 3k vector of plus S of 4i 4j minus 5k plus T of 7i plus j plus 3k vector. That's all. This is your final answer. Is that clear? Okay. So take your second question. It is given that show that the lines are coplanar. Show that the lines are coplanar. Also, we want to find out the Cartesian equation of the plane. So what are the two lines is given? X minus 2 by 1, y minus 3 by 1, z minus 4 by 3, and another line x minus 1 by minus 3, y minus 4 by 2, z minus 5 by 1. So what we want to prove? We have to show that these two lines are coplanar, and also we want to find out Cartesian equation. Is that clear? So we'll get into the solution. Now, from this one, numerator is your point, denominator is your vector, right? So numerator we can take it as x1, y1 is at 1, which is equal to 2, 3, 4. And second line, x2, y2 is at 2, which is equal to 1, 4, 5. This is your vector. Vector we can take it as L1, M1, N1, which is equal to 1, 1, 3. And L2, M2, N2, which is equal to minus 3, 2, 1. So these are the things we have taken from the question. Is it? So next we have to find out whether it is coplanar, right? So what is your coplanar condition? X2 minus x1, y2 minus y1, z2 minus z1, L1 m1 n1, L2 m2 n2 equal to 0. So we know your x1, y1, all those values, right? So subtract that, x2 minus x1. So what will be your answer? Minus 1, 1, 1. Next, 1, 3. This is also 1, right? So 1, 1, 3. And that is your minus 3, 2, 1. What we have to find out? We have to find out the determinant value. So if we find out determinant value, you will get this one, right? Okay, so this will be this will go off. So 2 plus 3. So this is your plus 5 minus 10 plus 5. Answer is what? 0. So we can conclude the two given lines are coplanar. Is that clear? Okay, so we found out coplanar condition. Next, what we have to find out? We have to find out the Cartesian equation, right? So question, we want to find out a vector equation of a plane in which they lie. So your equation of plane, so this is your equation of the plane. So what is your equation of plane formula? X minus x1, y minus y1, z minus z1, L1 m1 n1, L2 m2 n2 equal to 0. This is your finding equation of plane. Okay, so we just substitute the values, that is x minus 2, y minus 3, z minus 4, 1, 1, 3, minus 3, 2, 1, which is equal to 0. So if we take this one, x minus 2 of minus 5 minus y minus 3 of 10, next z minus 4 of 5, which is equal to 0. Again we have to simplify this, right? So minus 5x plus 10 minus 10y plus 30 plus 5z minus 20 equal to 0. Again if we take minus 5x minus 10y plus 5 is that plus 20 equal to 0. Again if we divide by minus 5, you will get x plus 2y minus z plus 4 equal to 0 is your final answer. This is your equation of plane. Is that clear? Your fourth question. If the straight lines, two straight lines are given, and they said this, if these two straight lines are coplanar, we want to find out the lambda and also Cartesian equation. Okay, coplanar, two lines are given. Which formula we have to use? x2 minus x1, y2 minus y1, z2 z minus z1, and Lm, like that determinant equal to 0. Coplanar. Cartesian equation now, x minus x1, y minus y1, z minus z1, L1 m1 n1, L2 m2 n2 equal to 0. So same as like your second problem. Okay, so two lines are given. We want to find out lambda and Cartesian equation. And what they have said, since it is a coplanar, right? So since the lines are coplanar, what is the condition? x2 minus x1, y2 minus y1, z2 minus z1, L1 m1 n1, L2 m2 n2, which is equal to 0. Correct? Okay. What is your L1 m1 n1, L2 m2 n2? This is your x1 y1 z1, x2 y2 z2. So we have to subtract this one. We can take the points here, right? So your x1 y1 is at 1 is what? 1 minus 1, 0. Next, x2, y2 is at 2 is minus 1, 0. Okay, wow. Okay, now x2 minus x1. So this we will get. Okay, we can take like this. So it will be 2, 1 minus of minus 0, minus 1 plus 1 is 0. This is also 0. And this will be a 2 lambda 2, 5, 2 lambda, which is equal to 0. Is that okay? Next. So we have to find out the determinant of this one. So if we take 2 lambda square minus 4 equal to 0. So lambda square minus 4 equal to 0. Lambda square equal to 4 implies lambda equal to plus or minus 2. So what is your lambda value? Minus 2 plus 2. So we found out lambda. Next, what we have to find out? Equation of plane. Equation of plane. So what is your equation of plane formula? X minus x1, y minus y1 is at minus z1, L1 m1 n1, L2 m2 n2, which is equal to 0. Okay, so first case we can take lambda equal to case 1, lambda equal to minus 2. So instead of lambda, what we have to substitute? Minus 2. So this equation will become x minus 1. We have to substitute x1, y1, z1 also. So x minus 1, y plus 1, z. 2 minus 2, 2. 5, 2 minus 2, which is equal to 0. So we have to define this one. So this is plus 4 minus 4, and you will get minus y plus 1 of minus 4 minus 10 plus z of 4 plus 10. And again this whole term will get 0. So minus y plus 1 of minus 14 equal to 0 plus z of 14 equal to 0, right? So this will be 14y plus 14 plus 14 z equal to 0. Divide by 14, you will get y plus z plus 1 equal to 0. Is that right? So again, what we have to find out? When lambda is equal to 2. So your case 2 is what? Lambda equal to 2. Instead of lambda, what you have to substitute? Equal to 2. So this will become 2, 2, 2, 5, 2, 2, which is equal to 0. Again, if you simplify this, you will get y minus z plus 1 equal to 0 is your final answer. Is that clear? And next is your finding angle and distance. Next exercise is your finding angle and distance. So your first one is angle between two planes. This angle between two planes already we saw in your second exercise or third exercise, right? So angle between two planes is theta is equal to cos inverse of mod n1 vector dot n2 vector by mod n1 vector mod n2 vector. And next, what we are going to see is angle between line and plane. So one line will be given, one plane will be given. Have to find out the angle between angle between line and a plane. So theta is equal to sine inverse of mod b dot n vector by mod b vector mod n vector. So these are the two things finding angle. And next is your perpendicular distance. So we are going to find out distance, that is perpendicular distance from a point with position vector. So one point and one distance will be given. How to find out the distance is mod u dot n minus p by mod n vector. So here this u is your position vector and we are taking the plane r dot n vector is equal to p. So one plane and one position vector will be given. You have to use this distance formula. Okay, next, distance between two parallel planes. So distance between two parallel planes is mod d1 minus d2 by square root of a square plus b square plus c square. Okay, these are the two distance formula. And next is your equation of plane passing through the line of intersection of two planes. So here two planes are given, r dot n1 equal to d1 and r dot n2 equal to d2. So we are taking two planes and we are going to find out equation of plane passing through the line of intersection. So line of intersection passing through this two plane, what is the formula? R dot n1 minus d of plus lambda of r dot n2 minus d2 equal to 0. Is that right? Okay, so this is your equation of plane passing through the line of intersection of two given planes. Next, position vector of the image point. So here we are taking one plane. Okay, so here we are taking one plane and we are taking one point A. So here we are taking one point A. So what we are going to find out is image of a point in a plane. So we are taking one plane and we are taking one point. We are going to find out the image of this point. So image of this point, how can we find out? Is your reflection point, right? So here this will be your A dash. This is your image point. So what we are going to find out, this is your point. Okay, so this is your point, this is your plane, and this is an image point of a plane. So to find out image point of a plane, we are going to use the formula v vector is equal to u vector plus 2 of p minus u dot n by mod n squared. So what is this v? V will be a position vector of the mirror image A dash of A. Okay, and always we know this A dash is perpendicular to the plane, correct? Okay, so these are the formulas. Okay, so go through these formulas and based on this formula, the formula problems we can sit in the next class. And your homework is exercise 6.8 third problem, example 6.45 and 6.46. Thank you, students.